This is the first of several videos that are going to deal with periodic trends in the periodic table. And this video is going to just set the stage. We're going to talk definitions and concepts. We'll go into the actual trends in the upcoming videos. But this is our introduction now to the periodic table and the reason it's called periodic. Now, we're going to look at some definitions, and the first is periodic. Now, the lay public, or the unwashed masses, tend to believe that periodic means occasionally, but that's not true. Periodic is something that occurs in a cyclical repeating pattern. For example, your cell phone bill. You know that you get your cell phone bill monthly, so you would say that the period is a month. As a matter of fact, for this person, it shows up on the 5th of every month. So when this person gets their cell phone bill, they know it's the 5th of each month. That's periodic in general. If you're referring to the periodic table, we refer to periodic trends. And this is a predictable, recurring variation or property with increasing atomic number. And of note is the fact that the atomic number is not periodic, it is continuous. Within the periodic table, we have things called periods, which are rows in the periodic table. As a matter of fact, there are 7 periods on the periodic table. Then we have groups. Groups are the columns in the periodic table. And when we talk about trends, we will talk about trends in periods and in groups. Valence electrons. Those are the electrons in the outermost energy level. And going by my dichotomous world, there are non-valence electrons, which are the electrons not in the outermost energy level. Now, if you are looking at the electron configuration, the valence electrons have the largest number in front of the orbital. For example, gallium. This is the electron configuration. We see that the largest number is 4 in front of both an S and a P. So the 2 for the S and the 1 for the P means we have 3 valence electrons for gallium. Now here is a new definition called the effective nuclear charge, or the Z sub effective, usually referred to by students as ZEF, and I will refer to it that way because that's what you're going to do. The ZEF is defined as the size or the magnitude of the positive charge seen by an electron in the outermost energy level. The ZEF can be calculated by taking the total number of protons in the nucleus and subtracting the non-valence electrons. So, for example, sodium has 11 protons, it has 10 non-valence electrons, and so it has a ZEF of 1. The ZEF for oxygen, on the other hand, oxygen has 8 protons, 2 non-valence electrons, so it has a ZEF of 6. We'll come back to that in the future. Ionization energy, how much energy it takes to remove an electron from an atom. As a matter of fact, this gets broken down even further. The first ionization energy, how much energy it takes to remove an electron from a neutral atom. The second ionization energy is the energy needed to remove a single electron from an ion with a 1+ charge. You're removing a second electron. Here's the definition for the third ionization energy. And this can go on and on until all of the electrons are removed from an atom. We will be discussing atomic radius in the future, and that's the distance from the nucleus to the outermost energy level of a neutral atom. And an ionic radius is the same thing, only it's done for an ion. Electronegativity is how strongly electrons in a covalently bonded compound are attracted to a specific element of the compound, or in other words, an unequal sharing of the electrons. And last is electron affinity, which is the energy that is released when an electron is added to a neutral atom. You're creating an anion, and it's analogous to being the opposite of ionization energy. When we get to the other videos, we'll be looking at 5 periodic trends, and these will be ionization energy, atomic radius, ionic radius, electronegativity, and electron affinity, the things we just defined. Now, there's an important definition that you need to know, and that is, what is an explanation? An explanation is the reasons or a justification given for an action or belief It is not a description. Example, you see somebody shivering and you go, why are you shivering? The person says, I'm shivering because my body is shaking. That is not an explanation. This just restates the observation. By definition, shivering is your body shaking. The explanation is, why is your body shaking? Why are you shivering? So let's look at the question again. Why are you shivering? I'm shivering because my body temperature is low. So what? So my muscles are twitching. So what? Which combusts more glucose. So what? Which causes a release of more heat. So what? Which causes me to warm up. I am shivering because it causes me to warm up based upon the steps just outlined. That is an explanation. When it comes to the periodic table, there are two frequently used reasons to explain the periodic relationships. The first is electron configuration, which you know about, and the second is called Coulomb's law. And the electron configuration frequently plays into Coulomb's law, but you don't know Coulomb's law yet. So what is Coulomb's law? Coulomb's law determines the force of attraction and repulsion between two electrical points. Like charges repel, opposite charges attract, and we can consider electrons and the nucleus to be point electric charges. The equation for Coulomb's law is F, or the force, is equal to K, a constant, times Q1 times Q2 divided by D2. We'll get to those. This is a quantitative statement. You can calculate out the actual value of the force, but we don't need to do that. We can deal with what's called Coulomb's relationship. The force is related to Q1 times Q2 divided by D. This is a qualitative statement. I can't come up with the official value for the force, but I can get a value that allows me to compare the force under one set of conditions to another set of conditions. So let's take a look at this qualitative statement. First, if the force is greater than 0 or positive, the force is repulsive. Secondly, if the force is less than 0 or negative, the force is attractive. So the strength of the force, when you're talking about how strong the attraction or repulsion is, depends on the magnitude or the absolute value of the force, not the sign of the force. So what do the letters mean? We know that F is the force. Q1 will be the Zeph. That will always be a positive number. Q2 will be -1. That's the charge of an electron. D is the distance from the nucleus to the electron of interest. So for here, in this relationship, F will always be a negative number because opposites attract. Remember, we are going to be looking at the magnitude of the number. The higher the magnitude, the stronger the attraction. Note that F is directly related to Q1. If Q1 increases, the magnitude of F increases. F is indirectly related to D. If the distance between the two charges increases, the magnitude of the force decreases. This slide needs to be memorized. The reason being is Coulomb's law, or Coulomb's relationship, will be used to explain things, but it's the one equation they don't give you on the cheat sheet, or at least they haven't in the past. So to review, you need to learn the vocabulary. Remember that explanations require reasons. They are not descriptions. For the periodic table, you need to know two reasons for the trends. We will get into that later. The electron configuration and Coulomb's law. Remember that Coulomb's law we will use quantitatively. So it's going to be the force is related to Q1 times Q2 divided by D, where Q1 is the Zeph, Q2 is -1, D is the distance between the 2 points. This ends the introduction to periodic trends. In the following series of videos, we will describe and explain the 5 periodic trends discussed earlier. Each periodic trend will have its own video. So onward and upward.